Hello everyone. During this video, we're going to talk about the Week 3 coding challenges. My name is Linda Gaston, and I am your instructor. Before we begin to talk about the challenges, let's review some of the Week 3 concepts. The first concept that's discussed this week is the concept of looping and iterating. In coding, we often have a need to do some set of logic more than once. Each time we go through that set of logic is called an iteration. So, if we have a banking application and we want to calculate interest for 20 accounts, we may have 20 iterations. A more simple example would be washing a car. You would follow this set of steps: rinse, soap, scrub, rinse, and dry. However, what if you had 50 cars? You would have 50 iterations of this sequence. Python has the concept of loops to progressively go through iterations. There are two main types of loops in Python: for loops and while loops. The for loop, like the while loop, allows us to repeatedly execute a block of code. However, it's generally used when we understand how many times we may want to execute a block of code. So let's look at that a little bit more. So when we know how many iterations we want, that's when the for loop is particularly useful. Let's talk about a special variation of the for loop. This is where the for loop uses a range function. This is provided as part of the set of libraries when you run Python, that comes when you run Python. So to loop through a set of codes a specified number of times, we can use this function. And the function comes with some default behavior. It automatically returns a sequence of numbers for you to keep count of your number of iterations of program logic. It starts from 0 by default and increments by 1 by default without you programming that. And it ends at a number that you specify. So let's talk about that a bit. So if we want to loop through a set of code a specified number of times, we leverage this range function. So let's look at an example. So let's say we have for x in range 6, print x. So this tells us that while x is in this range, from 0 up to this number 6, we're going to print x. So the range function defaults to 0 as a starting value if you do nothing. However, it's possible to specify a starting value along with the ending value. So instead of a starting value of 0 by default, in this particular example, we're starting at 2. And we're going to do this a specified number of times, ending up to, but not including 6. So for x in range from 2 to 6, print x. So we'll print 2. It will continue to default to increment by 1, so we'll print 2, 3, 4, 5, but we won't print 6. And you're going to see in some of the challenge questions that we will manipulate this second value if we want to include it. We'll simply add +1 to it, and you'll see that in a minute. So where does this x come from? We didn't program it. We just simply created this statement. X is our iteration variable, and it's provided for free by the Python language. So when you use this in range, you specify an iteration variable, and Python will take that and start incrementing it for you. You could call this anything. You could call it counter, as you'll see in one of our exercises. You could call it rubber ducky. It will continue to increment by 1 for you up to the value that you have specified here. In this particular example, the variable, this is really just a placeholder for your iteration variable. It will start at 0 and it will be incremented by 1 each time we go through this loop. So remember, we use for loops when we generally know how many times we want to iterate through program logic. We use while loops when we want to iterate until a certain condition is met. and we can execute those statements as long as the condition is true. So for loops and while loops are important to understanding the challenge questions. Let's talk a little bit more about while loops. In this particular example, we do know the ending value, but let's look at the structure. So we're going to start out with the value of I equal to 1, and we're going to say while I is less than 6. So while this condition is true, we'll continue to iterate through this loop. We start out with the value of 1 for I, so we'll print I, which is 1. Then we're going to add 1 to I. Notice the plus equal, just a shorthand to increment. And we'll continue to do that while I is less than 6. So we won't print 6 here because that is our upper boundary. This less than will stop us. If we wanted to print 6, we would say less than or equal to 6. Now let's dive into the challenge questions. In the first challenge question, we're going to count from 0 to n. Notice we use our typical import sys, the sys library, so that we can get our command variable, or our variable from the command line. So we get that variable and put it into n. Now, to count from 0 to n, we're going to create a counter for ourselves. We don't know how many times we want to do this counting because we're counting, and our upper boundary will be a variable given to us from the user. So we don't know what that value is. So this is a great application for the while loop. So we're going to say while our counter is less than or equal to the value that we get from our user. This less than or equal to tells us we're going to count up to and including the value we were given by our user. So at the beginning of this, we're going to print the counter, and we're going to add 1 to counter, and we'll keep looping while counter is less than or equal to whatever value we have been given here that we get from the command line. Notice we turned it to an integer. We're counting by 1, so that's probably a good idea. In this particular example, our input's going to be 7. So you'll see if you're given 7, your output from this exercise that you're printing will be 0, 1, 2, 3, 4, 5, 6, 7. Our next exercise in the challenge exercise will be counting from n to 0. So that tells us we're doing a countdown here from whatever value we're given in n, and we're going to count down up to and including 0. So we don't know the n value, so this is another great application for the while loop. We're going to get our n value in the typical manner. We're going to get it from the console, taking advantage of this sys library and this command. We're going to turn it to an integer, and we're going to put it in this variable n. We're starting our counter off at 0 because we want to count from n to 0. So while our counter is less than or equal to n, we're going to print n minus counter. First time through, it's just going to be simply n, right? Then we're going to increment our counter by 1. So now we'll be subtracting 2 from this value. The next time through we'll be subtracting 3, etc. Our input in this example is going to be 10. So let's take a look at how this would look. So we start out at 10. Now we're going to add 1 to the counter. So then we'll have 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. This next exercise is very interesting and a bit tricky. We're going to count from n to 0 or minus n to 0. So notice either you'll have a positive number or a negative number. So we're going to have to use an if statement to determine that. So if n is positive, then we're going to output all values from n down to but excluding 0. If n is negative, then we're going to output every value from n up to but excluding 0. Let's take a look at the code for this challenge. So we get our n value in the typical manner. We're going to use a counter variable to help us out here in our calculations. So we're going to determine first if we have a positive or a negative number. So if we have a positive number, we're going to count from that positive number down to 0. If we have a negative number, as in the case of n being less than 0, we're going to count up to 0. Now notice the structure. We have an if statement with a while statement embedded in it. So I want to point out, for your code to be accurate, make sure you indent. In Python, this is very important for it to understand the beginning and ending of the if statement and the beginning and ending of the while statement. So if n is greater than or equal to 0, we have a positive number. And while our number is positive, we're going to print n and we're going to subtract 1 from it. And we'll continue on until we get to the case where it equals 0. As long as it's greater than 0, we'll keep printing. In the case where it's equal to 0, we're going to stop, because remember, we don't want to print 0. In this example, in this if statement, this is if the number is less than 0, meaning we're starting out at a negative number. While that number is less than 0, we're going to print it and add 1 to it. So if it's negative 8, we'll keep adding. We'll go from negative 8 to negative 7 to negative 6, so forth and so on. But when it equals to 0, we stop, because we don't want to print 0. We want to exclude 0. The next one is a times table. In this particular exercise, we provide you with a number n. You're going to get that from the console. And you're going to output the times table for that number from 1 to 12. So you're going to multiply your number times 1, times 2, times 3, times 4, all the way up to 12. So if you were given 6, your output would be 6 times 1 or 6, 6 times 2 or 12, 6 times 3 or 18, etc. See how we're going from 1 and we're incrementing? Finally, we want to go up to 12, and that would be our last value. 6 times 12 would be 72. Let's take a look at that in code. So we're going to get our n value, and we're going to, this time, since we know our upper boundary, we're going 1 to 12, we're going to use a for statement. And we're going to make it easy by using the for in range statement. So we're going to start off with the value of 1. Remember, if we specify nothing, it's 0. We're going to start off with the value of 1, and we're going to go to 12 plus 1. You notice I said we would talk about a case where we wanted to include the upper boundary. If we just simply say 1 to 12, our program would stop at 12. So we're going to add 1 to 12, so we end up with 13. Now we will include 12 in our calculations, and we'll stop at 13. Now, in this case, we're going to print n times x. X will continue to be incremented 1, 2, 3, 4, 5, and we'll test each time to make sure we haven't gotten to 12, and we'll print. So this is what your values would look like, as we've discussed. Let's talk about factorials. If you remember from your high school mathematics, a factorial is expressed this way. Some number with the exclamation point looks like this. That number times itself, progressively increasing. Okay, so itself minus 1, itself minus 2, itself minus 3. So if we have 4 factorial, it would be, you start out with 4, so this is the 4, times itself minus 1, that's 3, times itself minus 2, that's 2, times itself minus 3, etc. Okay, that gives you the 1. And if we add these values together, we end up with 24. Let's look at this in code. One way to solve this problem in code is to use a helper variable called product after we get our n variable, which tells us our starting value for x here. And we're going to use a simple for in range statement. So we're going to start out with I, we'll let it default, and we're going to go up to n, which is going to be the value our user gives us. So we're going to use a helper, this helper product here. Product is going to equal product times I plus 1. And then we're going to print product. So let's take a closer look at this code. So here's our code. We're going to start out with product with an initial value of 1, and then we're going to use our increment variable I here up to the variable that we've been given, and inside of this for loop, so we're going to keep looping here, and when we're done we'll print product. We're going to take that product and we're going to make it equal to itself times I plus 1. Now for this to make a little bit more sense, let's include a little table here. So in this table we're going to put our value of product and we're going to put our value of I. So the first time we go through the loop, product is going to equal a value of 1. Then we're going to do our I in range up to the value that we've been given. So the very first time we're going to have, since we didn't specify any starting value, product is going to equal 1, I is going to equal 0. But then we're going to say product equals product times I plus 1. So if you look at it now, the product value, our product value starts out as 1. In this particular case, I is 0, but we're going to change our value of product to product times I plus 1. So it's going to be equal to product times 1 in this case. So now product is going to be equal to 1. So we hit the end of the loop and we go back again. This time we're going to increment I. I is going to equal 1. So now we have product, which is currently still 1. It's going to equal, it starts out as 1 here. It's going to equal product times I plus 1. In this particular case, I is 1, so it's going to equal 1 times 2. So in this case, it's 2. Then we hit the bottom of the loop and we go back up to the top. But when we go back up to the top, we increment I by 1, which makes it 2. Our product value is going to be now, product's going to equal now 1 from here, 2 from here, and product is going to be equal to product times I plus 1. So it's going to be equal to product times I plus 1, which is 3, and so we get a total value of 6. So if you continue to calculate these values in this manner, you will get to a value of 24. Try it for yourself. Next, we're going to do a challenge question where we're going to get a value of n, and we're going to calculate the sum of each of these values squared, each of the n values squared from 0 up to and including n. So if we got a value of 3, we would calculate starting at 0, we'd go to 1, 2, and 3, and we would square each of these values for a total of 14. So in this particular case, the value that we're getting is going to set the upper boundary of how many times we do the squares. Let's see what that looks like in code. So we're going to get our value from our console. We're going to put it in n. We're going to start out with the helper variable called sum, and we're going to set that equal to 0. So now we're going to use the for loop. We're going to go for x in range from 0 up to n plus 1. And we're going to progressively calculate the squares. So we're going to say sum equals itself plus itself times itself. And then we're going to print sum. Now if you calculate this through, stepping through each one of the increments here, you'll see that if you were past a value of 3, you would have a total of 14. This next one uses exponents. We're going to get two values from the console, x and y, and we should calculate x, which is the base value, times its exponent to get to the final result. So in this particular example, we get our base x value and y the exponent. We're going to use a helper value here called total. We're going to set it equal to 1. So if y equals 0, we're simply going to print total. And you may recall from your high school math again that any number to a power of 0 is 1. So we're safe to say if we get a y value of 0, total is going to equal 1. Otherwise, we're going to have to calculate the sum of the squares, and that's what we're going to do here in this else statement. So we're going to start off with I in range from 0 up to the exponent value, because remember we're calculating the sum of the squares of each one of the exponents. So we'll keep progressively increasing I, and we'll take our total, and that will equal total times x, and then we'll print our total. The next challenge question is related to the Fibonacci sequence, and as you may know, Fibonacci is a special sequence of numbers that looks like this: 0, 1, 1, 2, 3, 5, 8, etc. The pattern here is that you start the sequence with a 0 and a 1, and you continue to calculate out by adding the sum of the previous two numbers. That's why you need to start with 0 and 1. So if we start here, we get this value of 1 because it's the sum of the previous two numbers. As we move on to 2, we get a value of 2 because it's the sum of the previous two numbers. We get a value of 3 because it's the sum of the previous two numbers. Okay? And that's how we calculate the sequence. So let's see if we can do a Fibonacci sequence in code. So let's use a little matrix to help us calculate the values. So we have a helper variable of 1 here that goes in a variable called next. We have a variable called current that gets a value of 0, and Fibonacci, which starts at a value of 0. Now let's start going through our for loop. Now we do know the upper boundary of our for loop. It's simply n plus 1, so a for loop is appropriate here. In the first iteration, when our counter is 0, remember we're using an in range, so we start out at 0. In the first iteration, our values are simply the counter of 0, our value of next equals 1, our value of current, which equals 0, and our value of fib, short for Fibonacci, which is 0. These are given. Right here at the start, we haven't done anything yet. We're going to print Fibonacci. So in this case, we get our first 0 in the sequence. Now we move through to our next iteration. In this iteration, our counter is 1 because remember, we increment each time we hit the bottom of this for loop when we're using the in range. So our counter is 1. Now let's understand what would be our next variable. Let's see how we get there. So Fibonacci is going to equal next plus current. So we get a value of, current hasn't changed yet, so we get a value of 0 here. Current is going to change to the value of Fibonacci. So remember, we just calculated Fibonacci as a 1, and that goes here. On our next iteration, our counter gets incremented to 2. Remember these values here. We're going to print Fibonacci, but then we're going to change its value on our second iteration, and we're going to say Fibonacci equals next plus current. Well, these are the values that are currently in next and current from our previous sequence because we haven't changed them yet. So Fibonacci gets a value of 1. Now let's look and see what happens to our next values. Next gets equal to current, so it's going to be a 1, and current gets equal to Fibonacci because it's going to be a 1. So this is how things look at the end of our second iteration. At our third iteration, we're going to print Fibonacci. Its value hasn't changed yet, so we get the value from the second sequence. Okay? And that's what we print. However, in this third sequence, we do change it, and we say Fibonacci equals next plus current. So we say Fibonacci equals next plus current. So in the third sequence, Fibonacci changes to a 2. In this sequence, we make next equal to current. Here's our current value. We haven't changed it yet. And current becomes equal to Fibonacci, which is 2. So if you keep stepping through these, you'll see how you progressively calculate the Fibonacci sequence, as shown here. So if you have an input value of 10, your Fibonacci sequence would iterate from 0 to 10, and these would be the values that you print here. Try it for yourself. I used the following reference variables in this video: your textbook from Codio.com and W3 Schools, 3 schools which I encourage you to look at for their Python content. Also, if you have any questions about the challenge questions or the week 3 materials or any of the materials in our course, please contact me via email to set up a virtual office appointment. We can step through your code, I can explain concepts, and you can have a chance to improve your grade. Thank you for your time and attention during this video.